Hello class, this is Mrs. Groves. Today we are going to cover section 9.2 from our textbook. We're going to talk about one-sided significant tests for a population proportion. And the population proportion is P, and remember that proportions are percents. So today we're going to do two examples. I'm going to walk you through the first example, and then the second example, I want you to pause the video and do it yourself and then come back and check your work. So let's get started. Example number 1. Can you be confident of victory? Jack is a candidate for mayor, running against only one other candidate, so he must gain at least 50% of the votes to be elected. Heading into the mayor election, Jack is feeling fairly confident that he will be elected by obtaining more than 50% of the vote. Suppose that a random sample of 100 voters shows that 56 will vote for Jack. Based on a poll of voters just before the election, can Jack be confident of victory? So the first thing we have to do is, this is a percent, we have to define our parameter. And our parameter is P is equal to the true proportion who vote for Jack, and probably should say for mayor. Our null hypothesis is P is equal to 0.5. And our alternative hypothesis is that P is greater than 0.5 because we want to determine, does Jack win? So when I first did this, I made a little bit of an error. Be careful with your decimal places. If you're not given, for this level of significance, if you're not given alpha, then you use alpha equals 0.05. The conditions, we've been doing conditions for the last two chapters. They're random, independent, and normal. So in this case, we had a random sample, and that was stated in the problem. The independent condition, or the 10% condition, is that we had 100 voters, and we're fairly confident that there's at least 1,000 voters in this town. So we believe that that condition has been met. Now, we are doing a test of hypothesis. So we are going to be using, for our successes and failures, our null hypothesis. And this number I refer to as P naught. That's our null hypothesis. Our sample size is 100, 50%. So we have 50 successes, and that's obviously greater than 10. You need to show both calculations. So even though they're the same, you have to show that the n1 minus p is 50 greater than or equal to 10. Now, proportions are always z statistics. So this is one sample. It's a z test for p, or you can write for proportions. Now I'm going to switch over a little bit, and I'm going to talk about the sampling distribution and what you should be showing for work here. So n is our sample size. It's 100. Okay, this is p hat. So p hat is 56 over 100, which is 0.56. And our null hypothesis is P naught. Okay, and that might be a little bit small, so that's P naught p hat. Make it a little bit bigger. So this is really p naught equals 0.5. When we sketch the graph of a test of hypothesis, we're basing it on our null hypothesis. So based on our null hypothesis, okay, our population parameter, or the mean, p naught, is 0.5. And this is a right-sided test. Remember that we hope that we're going to find convincing evidence that Jack will win. So this area right here, we're going to calculate the p-value. And our evidence is p hat, and that is equal to 0.56. So this is a good graph to always draw. It's simple for you to do. It proves to the AP reader you know what you're doing. Okay, now to calculate the test statistic. The test statistic is a standardized z-value for this p hat and how far it is from p naught. So the test statistic is going to be z, and we want to know how far p hat is from the null hypothesis. Okay, and this is p naught 1 minus p naught divided by n. So you should be getting comfortable with this, being able to develop this formula, right? But you will have a calculator to help you with doing the work. So the p hat is 0.56 minus p naught, which is 0.5. Right. So this is in the denominator. It's going to be 0.5 times 0.5 over 100. And you can pause this video for a second and calculate that by hand so that you know how to do it. This is 1.20. When you're taking the AP exam, and if you're in a rush, make sure when you use your calculator, you show this, and you should show that z is 1.20. Now, get your calculators. And I'm going to show you how to do this with your calculator to find the z value. Okay, so you're going to go to the calculator. You're going to go Stat, Tests. Okay, so we're talking about proportions here. So this is going to be a, excuse me, one proportion z-test. The p naught, which is the null hypothesis, we said is, well, we hope that Jack gets more than 50% of the votes. X was the number of votes yes, which was 56. Okay. The sample size was 100. Now you have three choices here. This is going to be a two-sided test. This is a left-sided test. This is a right-sided test. You can arrow over, and you hit calculate, and you can see that our z is 1.2. And you can also see this P is going to be our p-value. So don't confuse that with the population parameter. That's our p-value. P hat's 0.56. So our p-value is going to be 0.1151. They typically like you to do it in 4 decimals. In this case, 3 decimals would be sufficient. Another thing that your calculator does nicely is it can show you this graph for you. So if we go back to Stat, Tests, we go to the one proportion z-test, and we go and say Draw. Look at that. All right? It gave you the graph. It gave you that your z-score was 1.2 and your p-value is 0.1151. So now we're going to show you how to calculate that p-value. So the calculator did it for us. You might get a multiple choice question. Seem to have lost my page, so I'm going to have to kind of cheat here. So to calculate that p-value, you're going to go to the p-value is the probability that z is greater than 1.20. We do that with normal CDF. So just make sure to keep on reviewing. Your calculator is going to be one of your best friends on your AP exam. So here we're going to go we're going to go second distrib, normal CDF. Our lower bound is 1.2. Our upper bound is some large number or positive infinity. This is a standardized score with a mean of 0, standard deviation of 1. Okay, and you can see that this p-value that you have here is identical to the p-value that we found right here using your calculator. We're now going to answer the next 2 questions. Okay. And this is, what is the interpretation of the p-value? If you are asked to interpret the p-value, right, this definition is one you're going to have to spend some time going over to make sure that you understand how to do it. Right? But assuming the proportion of voters who vote yes is 0.50. So you have to assume that the null hypothesis is 0.5. There is a 0.1151 probability of getting a sample proportion as far away from your p-hat, 0.56 or further, purely by chance. So that is typically going to be a question that's going to be a multiple choice question. You need to memorize that definition. Okay, so here you're talking about the null hypothesis and how far is p-hat away from the null hypothesis purely by chance. Now, there's 4 parts when you have to make your decision, your conclusion. Right? Since the p-value 0.1151. And we would say that that's a large p-value. And you should always think large p-value, fail to reject. Is greater than alpha equals 0.05. We fail to reject H naught. And we do not have convincing evidence Jack will win the mayor election. Maybe if he does another sample, he might get a better outcome. But based on this random sample, Jack should not be confident. So at this point, you should pause the video and you should do the next problem on your own. And I recommend that you use one of the templates to do it, right? Because this template is a great way to walk you through everything that you need to show when you do a test of hypothesis. And on the AP exam, you need to have all of these elements. They don't have to be in this order, but they all have to be there. So I'm going to take a break. I'm going to let you work on the next problem, and we'll see you soon to check in.